So hello everybody and welcome here and welcome to Andrei. Can you hear me, Andrei?
I can hear very well.
It's a joy to have you. I've been looking forward to this because I, like so many people, have been dreaming about when the future becomes three-dimensional. And given that, most of the things that people talk a lot about seems to be happening just on a screen, not in the physical world in three dimensions. So where are you now, Andrei?
Well, thank you first of all for having me. It's a pleasure to be here. I'm located in Edmonds, where the headquarters of my company, Jetoptera, is just north of Seattle in the beautiful Pacific Northwest.
Right. So I am actually, for random reasons, right now in Verbier, which is a ski resort where we're beginning to get some snow. And I've had some experiences here that I think was like a early look into the future, which is that I used to have, I lived another place in Verbier in the winter, and I had a neighbor, and he would he worked in Zurich in the financial industry, and every Friday he would go out from his last meeting around 6 o'clock. He would walk out of the building, across the street into a police station, just 100 meters from where he was. And there would be a helicopter waiting for him, which would fly him to Verbier. And so he would be in Verbier at 7 o'clock for dinner. Then the next morning, he would go helicopter skiing and do that the whole day, sometimes with me, sometimes with others. Same thing Sunday, and then at the end of the day, Sunday, fly back to Zurich so he could be at work Monday. So I thought that was a super nice lifestyle. Difficult to see though. There are around 9 million people in Verbier. Difficult, or in Switzerland. Difficult to see millions of people flying around in these quite noisy helicopters. But the future of flying cars, helicopters for everybody, whatever it is definitely getting closer. And in Supertrends, we have this machine algorithm where every day we check 5,000 different scientific and technical media for some keywords, and that produces a list of what goes on right now in different sectors. So we get thousands and thousands of stories every day, and we use AI to summarize them and put them into a timeline of human innovation. But we also use AI to make predictions, and then we check those predictions with experts, and you are one of the experts that have checked our predictions for this market. So when I look for, in a very broad sense, when I look at the predictions we have, I see quite a lot that is relates to military and space, which is not the area that you are focusing on. But of course, some of those technologies will be relevant. So I can see next year it is expected that you will have these coordinated drone swarms to work as decoys. You will have intercontinental attack drones. You will have military drones equipped with biometric recognition tools that are very efficient. You will have drones that can morph, so they can change from having, using fixed wings to not using fixed wings. You will have some that are hypersonic. But you also have, for instance, aircraft engines that are optimized by artificial intelligence, and many other technologies such as drag, reducing film quoting, and so on. But what we're going to talk about today is what will impact normal people in their daily life. And it's not about space, and it's not about military. I think it's about more happy, positive aspects of these technologies. So maybe you can start by just filling us in with your background. Why do we think you are one of the leading experts in the world? Why are you an expert for Supertrends? How did you get into that? What are you doing, and so on? And then maybe you can present something about how you see the industry.
Thank you, Lars. Yeah, sure. It's a fascinating field, isn't it? My background is I'm an aerospace engineer. Was educated on both sides of the pond. First in Romania, my country of origin. In Britain, I went to University of Manchester. to study aerospace and aeronautical engineering, they called it. And then I earned my PhD at Rutgers in the United States in mechanical and aerospace engineering. Right after that, I started working immediately for the giant called General Electric. At the time, it was Giant. In the research center, studying especially propulsion systems and power generation units, gas turbines mainly. Then GE sent me to Florence, of all places, where the GE oil and gas business, also oil exploration using oil extraction using gas turbines, was. I spent 2 years in Florence in Italy. And right after that, I probably reached the pinnacle of my engineering experience at GE, was transferred to GE Aviation, where I had a fascinating job. That was the technology integration and maturation manager for the G9X, which is a record-breaking largest turbofan in the world. And in my job, I kind of kicked the tires of something like 70 different technologies going into that humongous engine. The engine G9X is to power the 777X Boeing, which is now in certification. And it's very nice and reassuring to see the 777X flying over my head every now and then in the region where I am. At the time, I was working in Ohio. So in just a little bit of timeline, in 2013, Jeff Bezos started talking about drone delivery, that within 2 or 3 years, they will be delivering 90% of their goods via drone. Of course, we're today in 2024. I think Amazon spent something like $2 billion, and the activity in drone delivery is still somewhat small for Amazon, but I'm sure they're gonna get there. Then the timeline, one very important event what happened for me was, number one is I was done with the technology maturation and I wanted to move on. But the other one was the Kathmandu earthquake. And I was watching in dismay how for days people could not get goods in the mountains, completely separated. Helicopters couldn't fly in bad weather. And I was thinking, is it really drone delivery for Amazon, or is it something that we need to build something more powerful that can actually, deliver something much bigger, farther, and in bad weather? So that's how we started Jetoptera by I co-founded Jetoptera in 2015, June 1st, with 2 other co-founders, Dennis and Simina. And
Just
right
can I
from
just excuse me? Can I just ask you a couple of things? So you said the name very quickly. It's Helicoptera, right? Just so
Jetoptera,
Jetcoptera. Okay, sorry.
Jetoptera, and the name comes from jet and ptera, which means
Yeah.
wing.
And the other thing I just want to say, when you talk about drone delivery for important stuff, that I heard a very interesting podcast with that was Peter Diamandis, where he was talking with the founder of Zipline. And they actually now do drone delivery for Walmart, among others. But they began with hospital services, and they began, of all places, in Rwanda. I can never pronounce the name of that African country right, because it was very difficult to get the permissions for using the airspace and delivering things for hospitals and so on. So they simply had a meeting with the minister and say, "You'll be the first country in the world to get this if you give us all the permissions," which they did. And they managed to reduce death by birth. So by 52% in Rwanda, by being able to deliver blood and other emergency tools very, very quickly with these Zipline drones, which are drones that hover, and then they have this zip that comes down and deliver the goods without the drone itself coming down to people. So that was just an aside, but they now service about 4,000 hospitals around the world, as far as I could gather. So this is something that actually is beginning to work, but it took a sweet time.
It does because it's not simple technology. You have to You have to take into account so many other disciplines, from navigation to stability to propulsion systems, which is my main activity. But we were looking at electric drones and we were thinking, hey, look, this is not enough capacity. The battery is where it is, so we have to think about something that is more of a energy agnostic, if you will, propulsion system. That's how we came up with this fluidic propulsive system, which is a type of ejectors that has been tried before, not exactly our type, but it brings to the table very many aspects, very many things that actually can challenge what I see the legacy system to be challenged, which is the helicopter. In fact, in the advanced air mobility, as I view it, the way you tackle this, the way if you want to play in this market, you have to beat the helicopter. And I prepared a couple of slides to talk about this market. If I may start sharing a little bit.
Mm-hmm.
Just give me a second here. Let me know when you see my screen.
I see it now.
Okay. So this advanced air mobility has been developed. The concept of advanced air mobility, which in the beginning was called urban air mobility, but now has expanded a little bit, is actually a concept that was developed and driven by NASA, especially the NASA aims in California. But basically, what it means is the medical, the air taxi, the disaster relief. It has to be with low pollution, especially noise pollution. It has been studied that people cannot accept this sort of sorties, this sort of flights over the city or over their house if it's a noisy system. And as we know, helicopters are pretty noisy. But I'm jumping ahead of myself here. Cargo delivery and air taxi are, however, the main areas of focus right now. And what is very interesting is that it also assumes a low altitude flight. So we're not talking about going to 30,000 feet like commercial. We're talking about a restricted space at a certain altitude, not to exceed, in which this vehicles would operate. And obviously, if you look,
excuse me, Andrei, can you just tell us a little bit about the regulations for space, because I know nothing about this. I know that if you're flying where commercial airplanes are flying, you have some corridors, etc., and you are subject to rigorous flight control. But I have no idea what are the
yeah,
rules if you're flying lower.
that's absolutely right. So you have typically up to 400 feet above altitude that you're above ground altitude that you can operate in. And obviously that if the pictures that you see here are going to happen and vertiports are going to appear in cities, that's going to become very quickly a very crowded space. And we're talking here about drones that can do anywhere from filming around a building to drones that may clean the windows with tethered drones that clean the windows with pressured water. Or you can talk about air taxis. I think this was the original thought. However, in the meantime, because of the difficulties and the challenges in flying between buildings and above buildings, and the incident in Pan Am building in New York City where helicopters were pretty much banned from flying over tall buildings in the end due to this accident in the 70s. Now people have started talking about more of a regional service to the city. So basically, if you live in a more of a point-to-point air taxi, airlines are now talking about, hey, we're gonna give you a ride in one of these air taxis from large airports to your home. You no longer have to, take a cab or an Uber or so on. You can fly directly to your home. The challenge there is, of course, we're getting into the technology discussions, the battery, and this eVTOLs that, we're talking about several categories of vertical takeoff and landing vehicles. And these are the legacy systems, with the last category on the right being the emerging technology. So obviously, helicopters are dominating the space today. Like you said, with the gentleman that was commuting for skiing. Actually, when you said that story, I was thinking about another famous person who was doing that quite often. That was Agnelli. Agnelli from Ferrari and Fiat. He was
Right.
traveling from Turin to ski in the mountains, and then jumping off the helicopter in the Mediterranean to swim to the shore and so on. But the helicopter is clearly the dominating platform today, and they're very useful. You know, I was just reading the other day, first helicopter to fly was 1906, for a very short period. So long time of development, perfection of what they're doing. But they're slow, they're big, and they don't pretty much land everywhere. They have very serious restrictions, especially due to the fact that they're noisy. In many cases, you cannot fly it around the 24 hours. You have to fly in a certain time. Um, if if you want to go to a higher speed, then the tilt rotor is the option. But the tilt rotor is only so far a military application. And in spite of the Augusta efforts for the past 30 years to certify a civilian application, they have failed, and they have not yet certified a plane in that space. Then there, of course, is the Harrier, which is the brute force of applying jet power to take off, but very successful. And then the eVTOL. The eVTOL are, however, handicapped by the fact that the battery is a very heavy, low energy containing system. So this is basically the what we have today, the legacy systems we have today.
Can I just ask you a question there?
Sure.
So when it comes to when battery makes sense for transportation, there's a clear trend that for small devices it works fine. For big devices, it gets more and more problematic. And that goes also for trucks, for trains, and so on, where, yeah, you can have a scooter powered by battery, but a train by battery is really problematic, etc. Can you explain that? Why do we have this scaling issue?
Yeah, absolutely. It's a very short word in my answer: gravity. Okay, because all these applications that use battery on the road, road transport, even on the water, if you will, they don't fight gravity. But when you start talking about gravity, you have a completely different behavior. You have to use, for instance, an aircraft that needs to take off vertically has to use about 5 times more energy, more power
Mm.
to take off than when it's going forward and it's supported by the wings, what we call wingborne operation. So when that happens, it's very attractive to use an electric motor for that, because you say, well, I'm just going to apply more energy at takeoff, and then when I fly forward, I'm going to reduce that power. Very simple, and the motor stays the same. But for a normal aircraft, because you need a 5 times more powerful engine when you take off, like the Harrier, you have to oversize the engine. And then you end up with an engine that is too large for forward flight, and you have to do that because you want to take off vertically. But to your point, the energy density of the battery has to reach, in my opinion, in order to satisfy a serious business case for eVTOL, at about 1 kilowatt to 1.5 kilowatt hour per kilogram. And today, the best ones can only do 400 watt hour per kilogram. And that's only in small packages. So a long ways to go. There's another aspect, a couple more aspects that, it's not self-evident to people who are not in the business. For instance, if you fly intercontinental flights or even regional flights, you'll notice that your aircraft is increasing the altitude as it approaches the destination. There's a reason for that. As the plane burns fuel, it becomes lighter, As it becomes lighter, it can fly more efficiently if it goes to higher altitudes. There's a concept called Breguet range. Well, with the battery, you don't have the luxury of getting lighter. The battery is what it is. It's always stays the same. So because of this combined things, you are very limited in the range. And in my opinion, right now, any eVTOL that flies with people will only have a maximum 20 miles range, which
Right.
is without reserves.
Okay. Thank you.
Now, that being said, when you look at the market, and these are numbers, I didn't make them up. This is Morgan Stanley, Fortune, Mark, and some other people who studied this. The market that we know today, it's for sure, we know it and we understand it very well, is the helicopters market. It's about $49 billion. There's the emerging market of commercial drones. You mentioned Zipline. There are many others. And that's considered today, actually in 2022, it was about $30 billion commercial drones. It is highly anticipated that by 2040, this combined market, including general aviation, transport logistics, and air mobility, taxis, air taxis, will actually become $1 trillion. Now, in order to do that, obviously, what you need to do is you need to challenge the helicopter, because the helicopters dominate that market today, the vertical market. But the $520 billion is somewhat well understood, because we see the need, and if anything, the COVID-20 crisis clearly showed the need for drone delivery. If it's only for medication, sandwiches or coffee is one thing, but we're talking now larger, larger packages that people might need, maybe do several trips, and with several trips deliver to more people and so on. And at this point in time, it is anticipated that that market is going to grow significantly. The air taxi, the $460 billion, it's a little tricky, because we don't really understand this market. We don't understand if indeed there will be demand for hundreds of flights, takeoff and so on per hour. This is something, these are numbers that not even helicopters can do. So that's a little trickier to anticipate, but the nice thing about our technology, what we developed, is that we play a role in both. And we really started with cargo. We wanted to do things that help people with delivery drones. But in the meantime, the concept of air taxi has become interesting, and why not? So that's how we ended up with looking at that sector as well. So just a couple of concepts that are, there are some 200 and plus companies out there that promote an electric VTOL system right now, but they're all prisoners to, or they're hostage, if you will, to propulsion batteries. And propulsion batteries are very tricky. In my opinion, even if you get to those kind of levels of battery, 1,000 watt-hour per kilogram or more, that supports a business case, it's still very tricky, because the chemistry of the batteries will generate actually a bomb, because that energy wants to get out at once, doesn't want to get trickled to the system. So it's,
excuse me, just a question. Why is it called propulsion batteries? Why are you not just saying batteries? Is there any?
Because it's yeah. So this is an excellent question. Because the cycle of an aircraft, when you take off, you demand a lot of energy out of the battery, whereas when you fly horizontally, you slow
5
down
times less.
that trickle. So you see, the cycle of a propulsion battery is different from a battery that you use even in a car.
Right. Okay. Got it.
It's very demanding on the even on the chemistry,
right.
And you can run into issues. Then there's an emerging, as you probably heard, hydrogen. Can we implement hydrogen to this market? The question is that realistic or not, given the infrastructure and so on? So we can very easily go on a on a path of discussing all this. Is very large space, but basically, in a nutshell, what can beat the helicopter? That's what is going to be successful in this area. So I mean, I prepared here a bunch of numbers to explain the difference between other things, but the challenge with the battery is still there, and there's no magic battery at this point that can actually support a large deployment. That's why with my company we've focused on an energy agnostic system. Meaning what? Meaning that we can switch to an all electric system when the battery is invented, but in the meantime we're gonna try to stay with the typical jet fuel, diesel, or SAF, sustainable
Can I
aviation fuel.
just ask, from what you said earlier, I gathered that batteries would need to be 3 to 4 times as energy dense as they are today before they were really viable for many of the things you want to do. Is that correct?
That is very correct. Yes,
Yeah.
you can see the numbers right here. That this in the center of the page, the energy of the fuel, it's about the equivalent of 12 kilowatt hour per kilogram, and the battery, the typical battery today, is only 250 watt hour. So it's a big factor,
Right.
at least of 10 times. So this is where we are today with this technology. What we tried to do at Jetoptera is to get away from the propellers and the rotors. And our contribution there is to develop a system of ejectors, which is a device that takes a trickle of compressed air, amplifies it, and produces thrust on the same principle with a turbofan. However, with without blades. So very light, without blades, using this Quanda effect that we've been using successfully on a number of systems. You mentioned that military. We're not going to talk military here, but you sort of I think somebody famously said that if you want to succeed in this business, you will have to have some military aspect. And we did have 11 contracts so far in the 9 years of existence of my company, with especially because our system enables things like significantly lower noise. Why is that? Is because we don't have anything on the outside of the aircraft that can chop the air. So if you look at our system, is basically a bunch of non-round ejectors that we can distribute across the airframe. And at the core of the system, there's a turbine that compresses a trickle of air and distributes this air to the ejectors. That's how we operate. So because we're not chopping the air, we have no blades, we are toneless.
Excuse me,
And that,
you said there's a turbine. That means there is something shielded that chops there. Is that right?
yes,
Yeah,
the
okay.
turbine is usually, it's a turbo compressor. And another beauty of our system is that we can turn any turbo shaft engine that has already been certified. Okay.
Mm-hmm.
They exist from 100 horsepower to 5,000 horsepower. So it's very scalable, but we can turn that turbo shaft into a turbo compressor. It's a very straightforward system. So we feel pretty confident. And actually, earlier in the year, I went to a Kobe engine forum in Japan with a lot of participation of people with advanced air mobility interests. And I was very pleased to see that Honda is actually doing a hybrid system based on a gas turbine as well. So they use, instead of batteries, they're going to use a turbine that generates electricity on board, burning fuel, and then operate their propellers with electricity. So we are quite unique with our technology. You can see a bunch of pictures here at the bottom. We tested in the wind tunnels. We have a flight test bed. It's a glider that is only powered by our system, where we test various things. And we are now currently, you asked in the beginning, when am I going to get my flying car? Well, we like an approach where basically, as I said, do a cargo drone first and then scale it up to a two-seater first, what we call the J2000. And you see it here at the bottom, the concept. So next year, we partner with a Dubai company called Inan Al Sama for operating in Dubai a turbine powered 500 pounds, so about 225 kilograms drone that can carry around 50 kilograms of payload, but at very high speeds and in near silence. So this is where our first milestone next year, followed immediately uh, by working on the J2000, which is basically the two-seater aircraft. It's going to be more of a Ferrari, if you will, of the skies using our system. And these two dedicated platforms, these two platforms will be dedicated strictly for Dubai, but of course we have ambition to go beyond that market and operate across the globe.
So what is the business case? If I heard you correct, so the cargo version would be 50, up to 50 kilos of cargo?
Yes, correct.
Yeah, what is the use case for that?
The use case is immediate delivery. Instead of having to wait several hours, immediate delivery between cities like, for instance, Abu Dhabi and Dubai, transport to ships offshore. Instead of having the helicopters do that, ship to shore. That's something that we're looking for. But in general, also medication and other goods.
All right, so also missing spare parts for machinery like a ship or oil
Exactly.
field or
Oil
whatever.
platforms, exactly. Yep.
Yeah.
Yep. And as far as the air taxi, the ambition of so Inan Al Sama, the Dubai company, feels very confident about the market in Dubai for air taxis. The competition is getting very heated there, pun intended. It's very hot in there, by the way. Another thing that the battery might not like too much, I might add. But we're staying with the jet fuel for now, SAF potentially in the future. Even hydrogen is possible. I think that the turbine has a huge and very bright future in advanced air mobility as well.
Just question about hydrogen, because you've touched upon it a couple of times. You can have a fuel cell or you can simply burn hydrogen. So what is the case that you believe in most likely?
Excellent question. So fundamentally, the physics tells us that if you want to scale up a turbine, all you have to do is just scale it just a little bit by diameter. And if you look at turbines like the PT6, the turboprops, they're very similar in size, but one is 1,000 horsepower and the other one is 3,000 horsepower, with not too much difference in weight. That's because the energy is released in volumetric manner. For a fuel cell, it's a completely different story. You scale by surface, because a fuel cell uses surfaces that partition the fuel and the oxidizer. So if you want to double the power of a fuel cell, if you want to scale it up, then you have to double the volume, because you have to double the surface of the system. So to me, it's not a straightforward application of fuel cells for propulsion. However, I do see a bright future for fuel cells in aviation for what we call APUs, auxiliary power units, on larger systems, because there will be less noise than a turbine. Currently, all these large aircraft are using turbines for that as well. But I don't see the fuel cells scaling up nicely to large systems. The other challenge with hydrogen, you have to store it on board.
Yeah, which is a little bit dangerous in principle. Yeah.
Exactly. And I'll tell you one other example from what I learned, very interesting. This is more about the infrastructure. A NASA paper documented the amount of hydrogen, liquid hydrogen produced for the space shuttle program over 30 years. It turns out that for various reasons, boil off or venting for safety, 40% of that liquid hydrogen has been vented to the atmosphere. And this is not really a business case that I see to afford this kind of, maybe it's not going to be 40%, but this tells me that it's a major issue. You don't want to, vent away the hydrogen after you spend so much energy to produce it and to liquefy it. So the hydrogen story to me it's not a straightforward story. However, I see the SAF, sustainable aviation fuel, as being the low-hanging fruit if we want to talk about carbon emissions in aviation.
So that's synthetic jet fuel.
Absolutely, it's the jet fuel. It's absolutely identical with the jet fuel. In some cases, actually better because it has less carbon emissions. However, it's 4 to 5 times more expensive today. And the other trick is that they still need some hydrogen to produce it. But in the end, when you see these announcements with SAF being used for the, airlines bragging about it and all that, it's really brilliant chemists from companies like Exxon and BP and Total and so on that actually have formulated this SAF fuel to be identical with the jet fuel, because engine manufacturers don't change too much to use it. It's nearly identical to the jet fuel.
Andrei, we are going to take questions in about 5 minutes or so. I wonder if you wanted to address a little bit also society impact, how will this change business models, lifestyles, etc., when all the things you work on become mainstream and huge?
Yeah, I think we live in very interesting times with respect to logistics and with respect to transportation. I do see a very strong case of people traveling more point to point, not necessarily depending on going to large hubs, airports. I do see a lot of potential in regional air mobility. Again, small airports being connected with this type of technology. I think that those who will develop a technology that beats the helicopter in 3 categories: speed, noise, especially noise, and size, will actually succeed in having a growing market. That being said, I also see, I want to say, I cannot ignore the fact that if you think about it, with the conflict in Ukraine, the drone has single-handedly basically terminate the case of a tank. I don't think we're going to see armies in the world using a tank anymore when you can destroy it with a drone that is extremely cheap. So clearly the drones and UAVs have an impact on the society in general. And I think that we can do a lot of good, not only damage with drones, logistically, disaster relief, and so on.
I could also imagine that, for instance, in Europe, where I live, you have many areas that get deserted because, like so many other places, people move to the cities, the big cities still. And it takes too long time to get out to these areas. So you have, for instance, Sweden, you have these abandoned farmhouses that you can get pretty much for free. You have magnificent castles in France that are, extremely cheap and so on. And it's not because they're not nice. It just takes too long time to get to them. But if it gets easier, then some of these areas might become revitalized. But of course, a very big business case is the person who, let's say, like I've done, you fly into Charles de Gaulle Airport in Paris. It's fairly predictable when you will arrive, but it's completely unpredictable how long time it takes to get from the airport to where you have your meeting, which gets even worse when you have to go back because you have to factor in maybe huge extra time because you don't know how long time it will take. So you waste a lot of time because of the uncertainty, and these solutions can address that.
Yeah, absolutely. And I think you're going to see a gradual introduction of this type of services from airlines that want to offer something more to first class and business class passengers. An option where basically you would land to, let's say, LA, and if you live in somewhere else, in, Santa Barbara or something like that, you can actually take one of these air taxis rather than wait for another flight connection. So I think these are cases that may be more niched, but clearly these are going to be the cases that airlines are positioning themselves to perform in the future.
Why don't you take us through the last things you want to tell us about, probably technical, and then we take the questions after that. Is this your last slide you want to show?
No, I wanted to maybe talk about this system, how we envision this deployment of the fluidic propulsive system. We have 125 patents on this, by the way. So it's we spent a lot of money on legal protection for this system. But basically, you have a turbine that operates as a turbo compressor. You have your burning fuel. You can burn hydrogen. After all, the first ever invented turbine was run on hydrogen, so that's not a problem. Air is compressed. The trickle of air is compressed and delivered to a pneumatic system across the aircraft. And then in these devices that are the real patent, what we call thruster augmenters, we entrain massive amounts of air, up to 25 times air, and eject it out at relatively lower speeds than normal. So that helps us with the noise, but that helps us with also with the thrust generation. And the other nice thing about our system is that because we can make it non-round and it has no moving parts, we can make it work better with the airframe, with the wing. We have a concept that it's really neat and might enable a case for a high subsonic business jet, where basically we distribute this devices across a wing, and we retract it into the wing after vertical takeoff, enabling the aircraft to go as high as Mach 0.8. So imagine a business case where basically you take off vertically from your office, but you fly very fast to a ski resort that is not necessarily close, but 200 miles away, and you land vertically and refuel there. So this is where we're going with our technology, and we're very excited to have reached right now 1 kilonewton in one of these thrusters, so of a larger size. So other cases might be winging ground effect. That's intracoastal transportation. Again, we have concepts there as well. And even retrofitting general aviation systems for things like short takeoff and landing. That's another area of advanced air mobility that people are looking into. So I think with that, I pretty much covered what I wanted to cover. So I'm ready to take any questions the audience might have, or you might have.
I am looking at them. Are you looking at them also? We have from Ruben, question for Andrei. Which countries or regions are keen on regulating this technology for civilian air mobility? Do you want to take that?
Right now, currently, so there are two main agencies that are working with advanced air mobility OEMs, if you will, FAA in the United States and EASA in Europe. We are looking at deploying it first in Dubai, so therefore under the jurisdiction of the Civilian Air Authority in UAE. And that authority is more modeled after EASA. So that's how we're working with those authorities.
I take that as an answer. Then we have Andreas Bastholm is asking, are there any problems with flying VTOL across water to offshore assets? I can see you have a picture down at the at the bottom of the slide with
Um,
something flying over
yeah,
water.
that's
I take
yeah,
that as
that's
a
yeah. This is more of a, the picture at the bottom is more of a wing, what we call wing and ground effect. So this plane would float when it takes off the water and flies only over the water at half the wingspan altitude. So this is not going very high. It's regulated very interestingly in the United States. It's regulated by the Coast Guard, whereas in other countries around the globe is regulated by the Civilian Air Authority. So EASA in Europe and CAA in Britain. But that's one concept. Flying over water. Look, we're relying on a turbine, and a turbine is pretty much one of the most reliable things. We have concepts with 2 engines or 1 engine, so we feel pretty strong about that. But yeah, flying over water is a tricky one.
there's you make me nervous when you say it's half a wingspan over the water. There are things called waves, you know. But anyway, uh, the next one, and Anton Quintialedo, for you as well as, of course, will FPS be a game changer in the military industry? Are armies currently pursuing or considering this kind of propulsion?
Yes, so actually, this year was a very good year for us. We won a DARPA award as a subcontractor to a company that makes parafoils. So we power those parafoils. One of the concepts is to actually send via parafoils packages from far away and not only drop them on top of the target with resupplies. So we have several contracts in that area of powered parafoils. We have won 2 contracts with from an organization in the United States called AFWorks, which is the advanced technology branch of the U.S. Air Force. In that category, we investigated this high-speed VTOL capability of our technology, which is the Mach 0.8 capability of flying forward and with VTOL. And for that, we partnered with Pratt & Whitney, who validated our concept of turbo compressor, and with Northrop Grumman, who validated the airframe. And then we have the only branch we didn't do. So the short answer is yes. It's very interesting to the military because of the noise signature. Let's put it that way.
Next question is from Amanda Chidegel. So she was impressed by using drones for cleaning windows, but she asked about other everyday activities that can be handled by the aircraft types we are discussing here.
Yeah, I think I've seen with my own eyes a French company building drones for cleaning your roof with water pressure.
Mm-hmm.
And this is a tethered system, but there's many advantages for surveillance. Maybe if you're in a neighborhood that you need a rapid response. We've seen that actually probably everybody sees in the neighborhood every day. There was one thing, and it's probably not so much of the house, but one very important aspect we never talked about today is agricultural. That's going to be big because there are several advantages in using a drone for spraying, for instance, where it's allowed and required. The way they spray today with aircraft, it cannot be done during the night. And during the night is when some of these plants actually open up and they're ripe for spraying. So using a drone to do that kind of stuff is actually going to be big, in my opinion. It's going to be huge. it's also going to cost much less. So there are many applications, to be honest with you, that probably we didn't even thought about it. But I've seen even drones that are meant to do fire extinguishing in high-rise buildings.
Servicing giant windmills, etc., etc.
Yes. Yep.
We have Alina Pinteli. Did I say that right? If FPS will disrupt the helicopter market, how do you think helicopters will fight back? Normally,
Well,
normally existing industries don't fight back. That's my answer. But maybe you can.
well, I mean, you already see interesting fights on social media, on LinkedIn. I know for a fact that there's a big fight. Just the other week, the CEO of a large helicopter OEM fought back to the claims of the eVTOL guys and so on. But to tell you the truth, we are comfortable with disrupting maybe the light helicopter and maybe the medium helicopter. We just don't know. We can't anticipate at this point if we can scale it up to heavy helicopters. The beauty of our technology is that, again, we're toneless, so there's nothing they can do about this, right? I mean, they have rotors. The rotors are more efficient than us, I'll say that, but we have the advantage of noise reduction. So I'm not sure. I think I don't know, acquisition.
Right. I think we have time for two more questions, which I see here. One is from Anna Mendaluk. Which modes of transportation will be significantly replaced by urban air mobility first? Cabs, medical deliveries, or something else? So where will it really impact what happens in urban environments?
I
Pizza
think the
delivery.
yeah, I think urban environment is going to be a tough one, a very tough one. I can see a case for medical delivery. I still am very, very hesitant to say that urban transportation of people will be even doable at this point in time because of the certification and because of the noise. Quite frankly, as a company, I would be more comfortable starting in a regional transportation rather than urban. And I say this because you're limited in range. I think there will be very few people who would actually prefer to fly from an airport, 5-10 miles or out, rather than taking a public transportation or even a limo. That's
Right.
going to be very tough.
Okay, so if you are quick, then we can do two final questions. We have 4 minutes to keep the timeline. Sure. They're both questions are from Thorstein Freund, whom we both know. Yeah. They're of course for you also. The first one is, I'll tell you both of the question. The first one is, how do you see the future for lighter and affordable materials for the plane? So this is about graphite, graphene, etc. Versus steel, which is heavy but cheap. And the second one is, what is the minimum altitude for Jetoptera where you cannot hear it on the ground on the countryside? Is it 400 meters or what are we talking about?
Okay, perfect. Let me start with
the
second
3 minutes.
Question. 3 minutes, okay. So the first question is very easy. Yes, we're very excited about composites. We have actually manufactured our thrusters out of, you name it, 3D printed metal, 3D printed titanium, 3D printed thermoplastics. But the most exciting of all is we're working right now on a carbon fiber version that would weigh only about 2.5 kilos, but produce more than 1,000 Newton in thrust. So that's a very nice combination, and carbon fiber is it. In fact, our systems in Dubai will be built mostly out of carbon fiber. Your second question is tricky because when I see reports in the media about the noise, you always have to associate the noise with the distance. So what we tested for sure in 2 different methods, in an anechoic chamber and with a very advanced system called beamforming, we found out that we are at a minimum 35 decibel, no matter what the distance is, lower than anything that spins and chops the air, like a propeller or a rotor. Meaning what? Meaning that basically at, let's say, 120 feet, so that would be 40 meters, we will be lower than, we will be like sounding like the discussion we have now. This kind of level of decibels. Of course, we have turbo machinery on board, but that is a high frequency machine, so it's emitting a high frequency noise, and high frequency noise is very quickly attenuated by the atmosphere. Low frequency, like a propeller or a rotor, travel very far through the atmosphere without any attenuation. So we feel pretty confident that at 100 meters, to answer your question, or even 50 meters, you could barely hear our system.
That's very low.
Yeah.
Right. I think, yeah, so our time is past, and I think we have to keep the timeline. So thank you very much for joining us here. It's been super interesting for me, who knew a little bit, but not nearly as much as you have told me here. So I hope that anybody who wants to have more information from you will connect with you on LinkedIn or find you somewhere else.
Thank you very much for having me, and it's always a pleasure to talk to you, and congratulations for an awesome company that is Super Trends.
Thank you. Same to you. Take care.
Thank you.
Bye-bye.
Thank you all.